Last class we have discussed about the concept of what is a recursion, examples for the recursion binomial coefficient and also the Fibonacci series, example 1 and also example 2. So this is the 10th session of your class, chapter number 3. The topic is Q and recursion. Then going to the concept of the recursion, the example 3, greatest common divisor. So already you know the concept of the previous semesters, the recursion concept. So the GCD, that's the greatest common divisor, or HCF, that is the highest common factors. So what is the GCD or what is the HCF? So GCD of the two numbers is the largest number that divides both of them. So for example, GCD of 20 and 28 is 4 and the GCD of 98 and 56 is 14. So how it is calculated? So that is the explanation is in this algorithm. So this is the recursive function to return the GCD of the any two numbers. So suppose that A and B. So this is the function of the recursive function of a GCD of the two numbers. Int, it is a return type. GCD is a function name. Within the bracket A and B, these two are the parameters of the type of the integer. Then the opening block, if some of the conditions are there, if the A is double equal to 0, then it returns the value B. If B is double equal to 0, it returns the value A. Suppose if A is double equal to B, it returns the value A. So otherwise, if the A is greater than B, then return the recursive function GCD within the brackets A minus B comma B, or else return GCD A comma B minus A. This is the recursive functions for returning the GCD of the any two integers like A and B. So this is one general example. So 106 divided by 16. So which is equal to 6. The remainder is 10. The quotient becomes 6 and remainder become 10. Then the next recursive function, the 16 is divided by 10. So the remainder will be 6 and the quotient is an 1. Then the A is a 10, then B is a 6, which is equal to 1. So here the remainder is 4. Then the 6 divided by 4, which is equal to 1, the remainder will be 2. Then the next pass, this 4/2, that is equal to 2. The remainder will be 0. So once again I will repeat. So here the A is equal to 106, then B is equal to 16. So A divided by B, that means 106 is divided by 16. The quotient will become 6. Then the remainder will become 10. Then go to the next pass. So A is equal to 16, B is equal to 10 now. Then we can calculating the quotient become 1, the remainder become 6. Then go to the third pass. A is equal to 10, B is equal to 6. Then the quotient will become 1 and remainder will become 4. Then the next pass, A is equal to 6, B is equal to 4. Then the quotient become 1, the remainder become 2. Then the next pass, A is equal to 4, B is equal to 2. Then calculating, the quotient become 2 and the remainder become 0. When, so here is, if the B is double equal to 0, it returns the value A. So that the GCD of these two numbers 106 and 16 will become 2. So that means if the B is double equal to 0, it returns the A value. So that the GCD of the 106 and the 16 will become 2. This is the one general example for the GCD of the any two integers. So this is the recursive program for the greatest common divisor. So here is the first statements as include stdio.h. The stdio.h, it is a header file. It contains the number of functions like printf, scanf, gets and getch. Sorry, gets and put s and get char and put char. These are all included in the header file stdio.h. Then the next statement, int gcd, int a and int b. This is the recursive functions for finding the gcd of the any two integers. If the a is double equal to 0, it returns the value b. If the b is double equal to 0, it returns the value a. If the a is double equal to b, it returns a. If a is greater than b, it returns the recursive functions gcd a minus b comma b, or else returns gcd a comma b minus a. So this is the recursive functions. Then go to the main function. So every C++ program, the executions must be starts with this main function. And the a is equal to 98, b is equal to 56. Then after calculating the GCD of these two numbers, the output will be a 14. So it returns the value. So output GCD of 92 and 56 is 14. Then go to the example 4. Tower of Hanoi. So what do you mean by the Tower of Hanoi? The Tower of Hanoi is a mathematical puzzle where we have three rods and the n number of the disk. The objective of this puzzle is to move the entire stack from the one record to the another record, another rod. So it obeying the some of the following rules. So what are the rules? The first rule is that only one disk can be moved at a time, so that only one disk can be moved at a time from the one rod to the another rod. The second rule is each move consists of taking the upper disk from the one of the stacks and placing it on the top of another stack. So that means a disk can only be moved if it is the uppermost disk on the stack. So then third rule is no disk may be placed on the top of a smaller disk. This is the third rule. So these three rules for obeying the some of the rules for the Tower of Hanoi. So approach is that. So let's take an example for only a two disk. So let's the rod 1, that is A, rod 2 is B and rod 3 is C. First shift the disk from A to B, then shift the disk from A to C, then shift the disk from B to C. The pattern is the n minus 1 disk from A to B, then shift the last disk from A to C, then shift n minus disk 1 from the B to C. So this is the diagrammatic representation of this example. In the first diagram, that is the first rod, it contains only a three disk. B and C, these are all, there is a no disk. In the second diagram, that means the first disk is moved to, that is A to C. The B is blank. Then the next diagram, so here the A, it contains the one disk, the B is contains the another disk, C is contain the another disk. So here the moved the A disk to a B, that is A to B. Then go to the next picture. So here the C is moved to B. That means the smaller disk on the larger disk. Then go to the next picture. So here is we can move a disk from A to C. Then the next picturization, so that is fifth one. So here is then the B disk is the first B disk is moved to B to A. Then the sixth picture, here the B is moved to C. Then the last picture, A is moved to C. So here is the first A rod, it contains the 3 discs, then move to R. The C disc as it is like and same, the larger disc to and a smaller disc from bottom to top. So this is a Tower of Hanoi concept. So example, the input 2. The output is that disk 1 is moved from the A to B, disk 2 is moved from the A to C, disk 1 is moved from the B to C. So third input is disk 1 is moved from the A to C. So disk 2 is moved from the A to B. Then disk 1 is moved from the C to B. Then disk 3 is moved from the A to C. Then disk 1 is moved from B to A. Then disk 2 is moved from the B to C. Disk 1 is moved from the A to C. These are all the instructions which are the following these diagrams. So this is the recursive program for the Tower of Hanoi. So it contains the C recursive functions to solving the Hanoi puzzle. So it contains the void Tower of Hanoi. This is a function name. So n is a number of disk. So this is the rod numbers A, B and also C. So if the n is double equal to 1, that means only a one disk. So that is it moved from the A to C. So otherwise, if the number of disk is more, so that it is calling the recursive function, the functions which called itself. So here is, this is the main function, in the n is equal to 4, the number of disk is on a 4, the Tower of Hanoi can be, functions will be called. So this is a recursive program for the Tower of Hanoi. This is the end of this session. Thank you.